Hello and welcome to this video. Today I would like to give you a quick introduction in how to create a loop by using the parametric input method of SOFiSTiK CADiNP, and I would like to show you this on a simple example. I thought it might be quite useful to give you a really common approach in the building industry. It's about load patterns, and therefore I've created a small example, two-story building as we see here. Of course, there's a quite regular grid we can see. However, for today it's important that you get an idea how to utilize an available graphical input and create a more efficient workflow in regards using the CADiNP language, so the parametric input methodology, by picking up this loop function and putting loads on your structure. So what we are going to do in this video is the following. I will start with an already prepared example and I will go step by step through it to get at the end of the video a nice load pattern what we can use later on for our superpositioning. So the first step, what we are going to do, we are going to modify the structure in that way that we are going to assign different group numbers for the different structural areas we used for this example. Defining the group numbers is for this workflow I will show really important because later on we're going to use those group number information to apply the loads in the CADiNP in the parametric input. So what we are going to do is actually we assign for each of those patterns of our levels for the first floor and the second floor a different group number. So let's jump straight into the example. Therefore, I open my already prepared model here in SOFi+. So we see the structure already, and just to give you an overview what I have already here, I do have, of course, the entire project already prepared. However, what I haven't done is actually assigning the necessary groups what we need later on to use to assign our loads. So let's have a check. For instance, when I double click on one of the structural area, it gives me the group number 0, what is the default when I start using SOFi+ and my first structural area. And the group number 0 is assigned to all of the elements. So you see in the first floor and the second floor. So what we need to do in the first step is to actually assign this group number of the patterns we would like to consider to our project. So of course it's quite annoying because the project already gives you quite a lot of information and you can't see clearly through the examples. So I would like to show you, before I start assigning the group numbers, a small trick from my side, a little trick to make it much easier for you to keep track of the structure. So therefore I go on the side view and I open the filter tab on the left hand side in the sidebar, and I activate the structural filter. And I need the structural filter for a temporarily deactivation of groups. Before I do this, I will start with assigning the group numbers with the first floor. So I will now assign a kind of a dummy group number to this floor to isolate it from the entire structure. Therefore, I go to the structural elements, go on area, edit structural areas. I select this first floor, confirm with enter, and I assign, instead of group number 0, a group number 999. I apply, click on OK. So in the next step, I jump back to the activated structural filter and I open this drop-down menu here and show elements in group, and I deactivate the group number 1 and 0, and I can see now only my group number 999. I also would like to get rid of these AutoCAD lines, therefore I use the upper drop-down menu of the filter here and I switch off other AutoCAD objects. Here we go. I keep the supports here in the bottom. You could also deactivate them here, but I'm not interested yet in doing that. So in the next step, I'm going to assign now the different group numbers, and this will take a while because I do have 14 patterns here. So what I do actually is I simply double click on the first group. Oh, sorry, double click on this one, and I assign the group number 1. And you see, because I have only activated the group number 999, it will fade immediately here in my project. So I need to do this for each of the groups, for the elements. Of course, it's necessary, or not necessary, it's recommended to assign the groups already when you build up the structure, so you would save actually time doing it later on, as I did right now. So I have now assigned the group number 1 to 15 for my first floor, and in the next step I deactivate the structural filter again, and I do the same, assigning a temporary group number for my second floor to isolate it and assign the group numbers for the second floor again. So I use again 999, click on OK, jump back to the filter, activate the filter, and I go to activate this one over here, and I start the process from new. However, I'm now not starting at 16 for the next, because I'm starting a new floor. I jump with the numbering to 21 for my first floor. Again, double click on it, entering 21, and so on. I need to do this for all of them again. And the last one, number 35. Okay, that took a while for now, so I deactivate the filter, so we don't need to use the filter here again. So what we now actually have is we have two floor system over here with different groups for each of the different patterns. So to visualize the groups, actually you can use the structural element coloring, or the group visualization by using this coloring type over here. We can also swap to a conceptual design, so we can see it much better that we have used different groups here for our structure. So I switch back here to the wireframe because I prefer this view. Before we are going to export the structure, I would like to show you also the load case manager, because we have already load cases available in the system. This is something what I really like to do, especially when I export for the first time. I create a load case number 1 with the dead load information, so effective for the dead weight, simply to perform a linear analysis afterwards to see if my system I've created is stable. We have also actions available, the action group G and Q, so if for superposition later on, those actions are already available and I can assign the load cases to them as well. So I confirm with OK, and in the next step I export the structure to my database. So SOFiMesh C, Aqua and SOFiLoad runs through, and when I open my SSD, voila, we have the structure available. Good. The next steps for this workflow are creating the loads. We are going to enter the load information purely in the text file. We are going to perform a linear analysis, and then we are also creating an output, because setting up loops can also increase the efficiency later on for your outputs, for your graphics of the forces, stresses, or whatever you would like to present. To create loads based on a parametric input in CADiNP, we need to insert a TEDdy task. We can do that by right-click on my section loads, go to Insert Task, and scroll to the very end of your library of available tasks, and you find this text editor TEDdy task. Confirm with OK, and the teddy task will show up here. It makes sense to rename the task straight at the very beginning to keep track on your different tasks and also to organize in the best possible way. So to do that, use the right click and rename the task. I go for a name loads. In the next step, to start the input, I double click on loads. And you see already here on the top left of the white canvas, we have the blank and we can start coding more or less. We are now using CADiNP language to define our loads. To define loads, we need the program module SOFiLoad. So to call this module, we start with plus proc SOFiLoad. The next line, we are entering the headline. The headline also indicates what language you use for your CADiNP input. So available is German and English. So we stick with English, that's why we start with head. And I also enter a name of the headline, define loads. And to close a program module, it's always necessary to put an and at the end of the input. So now we have an environment of the program module where we can use different commands which are available for this specific module SOFiLoad. So to create a load, we need actually to define a load case beforehand. In SOFi Plus, this is done here in the load case manager and load cases. So here we have one load case available, and in that case it's a dead load. So however, we need to do that by using the text input. Jump back. Okay, so let's start the input. So I'm going to create a load case. If you're not, or if you start using text input with this example, you might be happy to get more support or understanding what actually happened in these different input lines. Therefore, I recommend using the F1 key. And by doing that, the interactive help opens. It's actually a PDF file which interacts with your input. For instance, what does it mean? If I click on head, it opens the corresponding help file or help PDF and gives you additional information of this specific command you have clicked on. So we are now in load case, and load case is a command of SOFiLoad. We see it here as well in the corner, and we get all the possibilities for this command. So load case means definition of a load case, and it starts from the top to the bottom. First of all, we need the load case number. So I'm now just creating a single load case to give an idea how it works. So I select load case 99 just as a dummy load case. The next is the type of the load case, and the type will be a none because I would like to use this just as a dummy load case. The next input is the factor, and the factor of this load case should be 1.00. So that's the load factor, so you have actually a possibility to multiply all loads defined later on by this factor. And then of course you can define a factor of the dead load, so the factor D, which is in our case 0.00. So I don't like to consider any dead load because I'm just interested to consider my single load case I will define later on. And last but not least, I need a title, and for the title I can enter a group number, for instance. Let's say group 31. Oops. Group 31. So I understand later on when it comes to post-processing or in the reporting, this load case 99 with the title group 31 comes with loads only on group number 31. So this is actually all what we need to do to create a load case. But however, this is just a load case and there are no loads actually available yet. We need to do that as well. And Therefore, we are going to enter an ARIA load because we are talking about structural ARIA loads here. And by entering ARIA over here, you see already the additional information we'll get from the interactive graphic. So there are some options available for structural ARIAs. For instance, for the reference, we have automatic, we have a load distribution ARIA, structural ARIA, group of beam elements, group of quad elements, and so on. As we have assigned already group numbers to our structural ARIAs in SOFi+, I'm going to pick the command or the reference Q group. So it's the quad element group over here. So I go Q GRP, and I forgot to enter ref. However, just maybe a few words on this one. There is actually not the need to enter this item before the literal or the input, as soon as it is in the right order from top to the bottom. However, if you jump between the inputs, for instance, you enter the reference, then the projection, and then the number, you need to enter explicitly the item that the program understands that you jump between the order. So however, to make it clear, I also enter reference over here. In the next step, I need to call the group number, and the group number is 31. And then I enter as well what type of loads I would like to apply. And for the type, I keep the direction in gravity, so the PG. There are also some description of the available options if you scroll a little bit further down. So we have PG for a loading in gravity direction, or PX, PY, PZ, and so on. So I stick with the default over here, the PG. And last but not least, we also need to enter a value of my load, and this is indicated by the P values over here. So we have P1, P2, P3, and so on and so on. This P values allows you to enter constant values. So if you enter only P1, a specific value, the load will be distributed constantly along the entire structural area. And this is what we are interested in. So I enter here a P1 value of 2.50, and the program understands, because of the units I've selected at the very beginning of the system information, that this is a kilonewton per square meter. And that's it actually. So we have now defined a load case number, the load case number 99. We have a structural area load with 2.50 only applied to the group number 31. So to check or control what we have done so far, I recommend simply calculate this task load. Great, green tick, that looks good. And let's check this in WinGraph as well. So we have the system over here. We get already the chapter loads, and I click on loads related to elements, all loads, and it asks me already load case 99 for the group 31. So you see already we have a load entered for this specific group number of 2.50. Great. So let's head back to SSD. However, of course you can do that now quite simply by copy-paste both lines to create for each of the different group numbers your loads. However, there's a much more efficient way to do that. It's the definition of a loop, and we are going to do that right now. So we keep that input over here. So I copy this one, use the Alt-C key command, the shortcut, to make a command out of it. So now let's modify these two lines now. To create a loop, we need the loop command. And every loop needs a variable which change along the different loop jumps. So therefore I use my hashtag 1. And every loop needs to be closed with an end loop. Here we go. Okay, however, nothing will happen yet because we need some more information from where to where should the loop actually goes. And therefore I need to set up a variable, and the variable will be a. Okay, if we would run now the example, we will run into an error because either the loop gives any further information nor the variable a is defined at all. Okay, let's define the variable a. And the variable a will represent actually our different group numbers. To define variables in SOFiSTiK in CADiNP in the parametric input, we have two possibilities. We can define it by let input or STO input. And for this example, we use the let input, which represents more or less a local variable, which is only valid within a program module. STO variables are also available in different modules. They are actually going to be stored in the database and can be called later on in different program modules. However, for this example, we use the let, the local parameter. So I start with let, and you see already the help jumps straight to the input, and we can also check some possible inputs over here. For this example, I decide to use this input here on the bottom by using the variable and indicating different numbers divided by a comma to initiate the different group numbers. So I start with hashtag A, and then I go for 1, 2, 3, 4, and so on until I reach my last number, and this is 15. So what the program now would do is runs through the loop 15 times. However, nothing will happen at all to our input because none of this parameter is considered yet in my input. So this is actually the next step, what I want to do. First of all, let's create the different load case numbers. So let's focus on this 99. So we're going to change this input. So as we have 15 different groups, I would like to generate as well 15 different load cases. And because of the fact we have 2 floors, I would like to start with the first load case, with the first group, with 101. So I start my first load case by 101. And then I add my hashtag 1 parameter, which changes actually for each loop. So my first parameter in the first loop, hashtag 1, will be 0. So when it runs the first time through, I got a load case number of 101 plus 0. So it's equal 101. In the second loop, it will get 101 plus 1. So it ends up of the load case number 102. So that's to the load case. In the next step, because at the end of the day you might going to use this load as well for a combination, and let's assume this is a variable load, we are going to use an action type Q for this one. We can leave the factor of 1.0. We will leave also the factor of the dead load by 0. But what I would like to do is also to make the title parametric. And therefore, I would like to do the following. I would indicate the floor, because I know the group number 1 to 15 is actually a group number in floor number 1. So I can also add floor number 1. Then I divide this by a comma and say also this should be the group number. And now it gets interesting, hashtag A, bracket, hashtag 1. So this input over here, this hashtag A and the hashtag 1 in the bracket, means it will pick up the item from the list in regards to this running variable hashtag 1. So in the first run, the number we get back from this input will be, you remember in the first run the hashtag 1 is 0. So it looks in the variable hashtag A on the location 0 and gives me back the value it's found. And the value 0 in the array is always the first entry. So we will get back group 1. In the second run, it will jump to my second location in the list. It will give me 2, and so on and so on. So that's so far for the load case. So we are now generating automatically a bunch of load cases, actually exact 15 load cases for each different group. And now we need to do also assign the right load to the right group number. So we can leave the reference GRP and for quad elements. However, we need to modify the group number, and therefore, I guess you will already know it, we will need the same input from here, because we want to pick up for each loop a different group number. In the next input type, we can leave the PG, and we can also leave the loads to 0.50. And actually that's it for this loop. So let's calculate our input. Go to right click on loads and calculate loads. And let's see what we got in WinGraph. Okay, so we have the load cases 101 until to 115. What we don't get is the numbering what I had expect we should get by using this input. So you see there went something wrong. So let's investigate what not was correct in the input, or what isn't correct in the input. So double click on loads, and sometimes it happens that the CADiNP language doesn't interpret a variable based on a list input. However, there is a kind of a workaround to get this done. Therefore, you define a temporary parameter within the loop, and therefore we use the let hashtag and name it GRP for our group information, and use hashtag A bracket hashtag 1, and we simply replace our input over here with this group variable. Let's give it another try and see if it works now. I right click, calculate loads, and fingers crossed, here we go, group number 1 up to 15. So when we go through the different groups, you see all loads are on the correct position. Great. Let's do the same for the second floor. I jump back to SOFiLoad, and you might already know the big advantage when it comes to text input is actually we can use copy paste, and therefore I copy the entire input and insert it here again. I can now just replace the inputs over here. However, show an alternative input, especially for continuous numbering or a list with continuous number. There's a smart way to avoid the single input of each number. Therefore, we have the possibility to write 3 values in the brackets. This is the start value, 21. This is the end value, 35, and an increment in between. So the program understands this input similar to a list of the values. So 21, 22, 23, and so on. The next steps, we can actually keep also the parameter A here and here as it is, because when it's going to be defined again, it will overwrite the previous information. So we can keep A over here. We can also keep the group parameter here. However, what we need to do is we need to change the load case number. If we don't change them, the previous defined load cases are going to be overwritten. So as we are working in the second floor, I simply replace the 100 to 200, and I also replace in the title the floor 1 to floor 2. I can also keep the input line over here as it is, because it picks up automatically the right group number from the list above. So let's calculate this as well and see what we get. I jump back in WinGraph, and here we go. We got as well the loads in the second floor. Awesome. So now we have all the single load cases. Now we can actually calculate them. And for the linear analysis, you do have now the following options. I can either import or add a graphical user task to my project tree on the left hand side, or I can enter all by text input using the text task. However, I would like to show you something in between. I first insert a new task and I use the linear analysis task. So when I double click on this task, all my available load cases will show up. So we got all this load case number 1, 99. As you remember, our test load case is still available in the database, and all load cases for floor number 1 as well as for floor number 2. So what I'm going to do now is I tick off the process immediately task information here, and I confirm with OK. So the program now actually saved my information in graphical user interface. And what I'm going to do now is, because I would like to show the workflow entirely in CADiNP, so text-based, I'm going to convert this graphical task into a text user task. Therefore, I use this option in the context menu, and you see I got now the same cyan-colored teddy symbol, which indicates this is now a text input task only. When I now double click on this task, I get all the text input or the same information what I have done graphically as well available as text input. However, you see the input is divided in two parts. We have the program ASE and we have the program model WinGraph. For our purpose, we don't need the WinGraph because I will show you this later on how we can do that more efficient for our outputs. So I split this input a little bit to explain it quite quickly. Again, we have the indication of the program module ASE, which represents the advanced solving engine. Then we have as well the head, which has the name calculation of forces and moments. Then we have an indication of the page. This is the default, so we can delete this, and also the control option, and we can remove this as well. And at the end of the day, for a linear analysis, you can stick with this input load case all. If you're only interested in calculating specific load cases, you can do it that way. You can start load case and start with the brackets 101 to 115 with an increment of 1. If I now go and comment this out by using Shift and dollar symbol, I will see that only load case number 101 to 115 is going to be calculated. So I go right click and calculate this here. Good, let's have a look in the visualization. So we see already, I just go with the amplitude of 100 and let's stop the animation. We got already nice all the results for our calculation. Okay, so let's do that as well for our second floor. Therefore I click on my line load case over here. I use the F8 key on my keyboard to clone the input line, and I simply modify my input from my load case 100 to 201 and to 215, and I keep the increment of 1. So let's run the linear analysis by using the right click and calculate linear analysis. And let's see if we get what we expect. Here we go, we have load case 101 to 115 and also 201 to 215. If I switch on a constant amplitude and stop the animation, we can go through the load cases quite nicely. So I save the project. So this is basically all you need to consider when it comes to create a loop. So let's have a look back to the loop. So you need to define a loop input line and an end loop. You need to apply a running variable #1 and also further information how often the loop should go, for instance, with this array over here. When it comes to the linear analysis, you simply use these two lines to calculate all the load cases to save the results. I would like to show you now how you can visualize all the results, because as you can imagine, to represent the different bending moments for each single load case is quite time consuming to set up everything by hand, and therefore I would like to show the input based on WinGraph. Therefore I create an interactive graphic in my task project tree, and I scroll down to additional modules and select interactive graphics. So I move that down to output. And next step, I open this one. And what I like to do now is I would like to create a kind of a template of a result I'm interested in. So for instance, this can be a plan view, and I would like to show a result from my quad element forces. Let's do bending moment mx. And I pick my first load case 101. Okay, and I also switch from this vector graphic to isolines. And I increase the font a little bit. So we see here, this is my first load case. I get a bending moment over here. When I go through the different load cases, this changes immediately. So what I like to do now is to generate for each of the different load cases a different picture, a different graphic. And therefore I use again the text input, and you might already know this. The WinGraph provides you quite a nice possibility, so you can put everything in your canvas graphically, but you can also utilize the CADiNP language in the background to optimize a mass generation of a lot of graphics. So the first step to do is save your kind of first idea of your graphic, and then use the start heading command over here, and this actually copies the information you have generated to a text input. And what I'm going to do, I simply copy this input over there with Control C. Then I can close Teddy again, and I can also close WinGraph. So when I'm back here, the program asked me to take over the changes I did in WinGraph. I agree, that's fine for me. And in the next step, I use insert task to insert a new Teddy task, as we did previously, because I would like now to import my text snippet from my WinGraph input. I also rename this to forces. I double click on this one, and I can use Control V to insert this text-based input from WinGraph. And this is actually my base information I'm going to use now to create my graphics more efficiently. I save the project and I get started. Don't get confused about all these inputs, just leave it as it is and just follow the input I'm going to do. So you see here an indication, this starts the first graphic. It's a picture 1, layer 1, and it's the bending moment MXX. So it's kind of very important to keep this input. Also, you can also recognize the load case information over here. So it's the load case number 101 and the design load case 1 by default. However, we are only interested in this 101 so far. Good. So what we need to do is, in the first step, we need to create the loop. So I need to put all this input into a loop. And as we learned previously, we actually need this loop over here. And to make the steps much easier, I simply copy paste this information. Okay, so I use this one, copy, and I paste it. Okay, good. So however, as we are talking about load cases, I can't use this group number anymore. So I start with 101 and end up at 115. Good. And Every loop also needs an end loop. Don't forget to use the end loop. Good, so now we have already created a working loop. However, nothing happened at all to my load cases. So I need also to indicate this loop information, the change of the load case. And therefore I'm going to change a little bit this input because I'm interested in extract this load case number from this array. So therefore I use, instead of grp lc for load case, it's easier for me to identify. So now the information of the load case for each run of the loop is going to save in this parameter hashtag load case. And all I need to do now is simply to change this constant number 101 to my variable load case. Oh, sorry, I need a hashtag over here. Good. And that's it actually. It's now going to generate 15 graphics with the bending moment mx for each of the different load cases. So what I do now, I save the project and I perform the calculation of this task. And here we go, we have a green tick and we see also it generates 15 graphics with all the information, the different load cases. Let's have a look into the report, right click and reports. Increase this one, I jump straight into the graphic tab. And here we go. This is my first load case 101. We can control it here as well in my footer and the legend. And when I click 102 and so on and so forth. Great, perfect. Let's complete the example by doing this as well for my load case numbers 201 to 215. So I go back to forces and I simply copy the entire input over there and change 100 to 200 and I'm done. Right click, calculate forces, and it now generates in addition further load cases for my example. I go to the report and we have all the load cases available for the second floor. Great. This brings me already to the end to this example. Just to wrap it up, the different steps, what we need to do is, in the very beginning, you need to define the groups along the scheme of the pattern you would like to consider by simply using the modify option and entering the specific group number over here. I recommend, if you build up your structure, also think about at the very beginning to divide already the structural area in the proper way when you're going to, or when you need to consider the load pattern afterwards. In the next step, you need to jump into the text input to prepare a first load case, kind of a template, and based on this, you are building up your loop. You have two options to consider the different groups numbers by entering it as a list by each of the values, or using this possibility over here with the start and an increment. I recommend, if it's continuously numbering of your list, then go for this option over here. However, if you have some spare numbers or some jumps in the numbering, go with an explicit input method here. You can also pick up the information of the array to use it in the title, which is quite useful, especially when it comes to the reporting tool, that you can identify the load case much easier. For the linear analysis, if you want to do it text-based, it's straightforward as well. So you see you need only those two lines at the very beginning, one end at the end, and the load case command to perform the calculation, the linear analysis. And also, last but not least, at the end of the day, you need to generate a report, and it's definitely a time saver instead of clicking through all the graphics in WinGraph manually, to utilize this possibility by putting a loop or wrap the graphic into a loop and generate the outputs much efficient as doing it by hand. I will also put a link to a description of the workflow on my website, so you can go through this as well later on. I hope you liked this video today. I hope you got an idea how you can utilize this loop functionality, or you can utilize in general CADiNP, the text input, to create a more efficient workflow, to speed up your processes, and also to make it more accessible to later on for modifications. If you found the video useful, please like it below, and also you're more than welcome to subscribe to the channel to be updated on all future videos I'm going to publish here on the YouTube channel. That's it for today. Wish you a very good day and hope to see you soon in one of my next videos.